Good morning and welcome to this IDEC webinar, The 4 Fundamentals to Consider when Selecting Your PLC. This is a basics introduction to the fundamental and elementary elements for PLC selection to ensure that we get the right solution for your application. Before we start, a few housekeeping rules. Firstly, this webinar will be recorded. Your microphones will be muted, and I ask for you to answer any questions or ask any questions using the right-hand side of your screen. So, firstly, a little bit of information about me, your host for today's webinar. Electrical electronics engineer as my background and training, and subsequently moved into advanced manufacturing technology, playing with lasers, robotics, and other advanced technology used in automation and manufacturing of aero engines. Subsequently, 35 years worth of experience within PLC and HMI hardware and software. Today, working on working to deliver workable solutions for many control systems and automation applications in various industries. With over 20 years experience within the IDEC family, I have a wealth of knowledge to share with everybody, and welcome to do so. Today, working within IDEC, I head up a team of business development and specialists across automation and safety in the EMEA territory. So a little bit about IDEC. If we look at IDEC's product range and split them into 5 categories, we have safety, both machine and process safety, industrial switches, automation, sensing, and industrial relays and components, or panel products. Today, of course, we'll be looking at PLCs in the automation section. Programmable logic controllers, or PLCs, fundamentally, it is in our DNA. It's in IDEC's DNA. We've been making PLCs or similar products for over 50 years. And if we look back to 1969, when IDEC launched its first simple step programmer, right through to the mid-80s when we were manufacturing PLCs, which look something similar to what you would see today, it forms a good foundation for us. If we look at the last 30 years, so since the late 80s, when IDEC launched its first micro PLC, and then subsequently grew from Micro 1 through Micro 3, FC4A, FC5, and subsequently today we have the FT1A series and the FC6A all-in-one and plus type. And those 4 series we will look at a bit later on in this webinar. In terms of unit sales in the last 15 years, across some of the FC4A, 5 and 6, we have over 500,000 CPUs sold. So, on to the main aspect of the webinar, and that is really to determine that a PLC is much more than just a simple selection of a part number. And what we're going to do now in the next few minutes is talk through the application basics that lead to the most appropriate product selection for your application. The 4 fundamentals, we're going to look at inputs, outputs, special functions used within the process, and communications. First up, and the first fundamental, are inputs. Input devices. First of all, let's look at the digital input, or DI. The digital signal, which is typically 24 volts in an application today, is a signal arriving from a device on the process or plant, which is arriving at the input terminal of that PLC. This signal is usually coming from a device on the machine or a simple switch on the control panel or somewhere on the process. This could be from a push button or a key switch or a selector switch. It could be from a sensor, which is detecting the presence of a part that's about to be worked on, or a carton on a production line. It could be from a limit switch on a door or a gate. It could be a high-speed input coming from a rotary encoder, determining speed or position. Or it could be a signal coming from a safety device. Of course, the monitoring contacts only, because the safety signals will be going through a different set of hardware. So this is our digital input. Simple 1 or 0. Then we move on to analog devices. An analog input typically is a signal which is a variable. coming from a device, could be a flow instrument, pressure instrument, a thermometer, or a thermocouple on your process, and arrives at a particular input on the PLC, either as a signal which is 0 to 10 volts or 4 to 20 milliamps. This could be coming from a pressure, vacuum, or flow instrument. It could be determining temperature, humidity, or pH, the level of liquids or solids in a tank, or even distance, speed, or position. This would be an analog input signal. On to the second fundamental, the outputs. Similar to the digital in, we have digital out. Again, a simple on or off state. This is a signal coming from the output terminals of the PLC, going to an external device in the control panel or on the machine or plant. And this could be a signal going to an electrical mechanical device like a relay or contactor, just switching its coil to pass signals further on. It could be a signal going to an indicator or a machine light, a stack light, or something similar on the machine to give indication to the user or the operator that some attention is needed. It could be a digital signal which is switching a valve or an actuator on or off, allowing the flow of air or water into the plant. Or it could be a simple signal going to a variable speed drive to say run or stop and run at a certain speed, or a signal going to a stepper motor or a servo. Of course, if we've got digital outputs, the chances are we've also got analog outputs. And here we have the analog out, again, typically a 0 to 10 volt or 4 to 20 milliamp signal, which is being used as a variable output, which is determined by the program or process within the PLC, which we'll talk about a little bit more in a moment when we look at the special functions. This analog signal typically is being used to drive something like a heating or cooling system to achieve a particular set point. It could be up to a pump or a motor, which would be a determining speed, or going to a proportional valve or actuator to ensure rather than just the valve is open or valve is closed, but we actually proportionally open that valve to allow a certain amount of air or a certain amount of liquid in through to the application. Or of course, it could be speed control. This is your analog output. The third fundamental we're going to look at are special functions. These are functions typically within the PLC that help the process work better. The first one on my list here, and this list is far from finite, is supply voltage. Now, whilst this isn't a special function, it's something that should be considered when selecting the right PLC. Does it need to be AC powered or DC powered? And typically the application might drive that, but we can offer solutions across these anyway. When we actually look at the functions, then we move into, let's say, the dedicated aspects that really do help us select the right PLC. And we start with high-speed counting. High-speed counting is a signal coming from a device, as it states, at high speed. This could be coming from a linear or a rotary encoder. So you have a series of pulses that the PLC needs to be able to capture and count or work on. And these signals typically go to dedicated inputs of the PLC, which are not affected by the scan time of the process. For your information, on the FC6A, we have 6 high-speed count inputs with a speed up to 100 kilohertz. Then we look at interrupts. Interrupts are similar to a high-speed count, if you like, but rather than a pulse train, it's one pulse that happens very quickly. The PLC needs to capture that and work on a particular subroutine away from the general scan time of the process, or the process or the PLC. So this interrupt needs to be captured and worked on. Pulse train outputs. Similar to high-speed counting inputs, the pulse train output is a series of pulses driven at high speed again. So here you would use a transistor output from your PLC because you wouldn't want to put that stress on an electromechanical relay. The pulse train then is being driven to something like a stepper motor or a servo, basically giving direction and speed through pulse trains. This leads us to motion control. These are somehow vicariously connected. PID control, proportional integral derivative. PID in itself is a bit of a black art, and we'll cover that in another session. But within our PLCs, we have PID control. And within PID, what you're able to do is to achieve a particular set point within a variable application to ensure that you hit that set point in a smooth manner, you don't overshoot, and then you maintain that heat or cool situation in order that you have good control of your process. So this is PID. Then we look at 2 other functions. Data logging, So a particular event occurs on your machine, on your application or your manufacturing line, and you want to be able to log that with a date and timestamp and the event, maybe the operator that was using the machine at the time. All this information can be stored within the PLC or even stored on an SD card. If you look at some of our PLC series, the FC6, they have embedded SD card slots where you can handle this logging function directly onto that card and then remove it and have a CSV file that you can then take into Excel and analyze. Similarly, recipe handling. Recipe handling now, you put the recipe onto the SD card and load those recipe data into the working area of the PLC on demand. So you're not putting overhead on the PLC for recipes that don't need to be there when they're only used once every month or less. Local message display. So we have the ability to have a small display on the front of some of our PLC series, and these local message displays are there either to give information to an operator or to allow variables or particular count information or variable data to be displayed to the user of the machine, and ultimately be able to adjust those variables as well from the front of that display. Then as we move into more of the IoT era of our hardware, of course, email capability within our FC6A series is there, and also web server capabilities. So with an email, you could send notification to the manager of the plant, a machine operator, or the maintenance guy to say that something is failed or faulty or needs attention, or even production information could be sent as an email with overlay data. And then we have web server capabilities. Here, you actually embed a complete website inside the PLC, often removing the need for a local HMI or touch panel because it's actually inside the PLC itself. Within our hardware FC6A Plus and FC6A All-in-One, this website is actually created not using HTML code, but actually created using the same graphical library that we use to create screens within our touch panels. So it's very easy to use. You don't need to be a computer programmer to set up a website inside our FC6A PLC. Use the same software as you do for our touch panels. So that's some special function that need to be considered for your application. Now the fourth fundamental is communications. Communication, what is industrial communications? Simply put, it's the backbone of the automation system. Note how I use the word system there rather than just machine, because with communications, effectively, you've got multiple devices talking to each other, so you're creating a more complex system. It's the exchanging of information between two or more devices, and is typically implemented using standard protocols, and we'll cover some of those soon. The way in which we make this communication work typically is over serial RS-232, which is a simple one-to-one network with a typical communication distance of between 10 and 15 meters. Then we have serial RS-485. This is a two-wire network that now can run between multiple devices, so it's one-to-many or one-to-n, where you can have several devices sat on the same network. And of course, as we see Ethernet growing more and more strong inside the industrial communication marketplace, this is something that's dominating now. And the majority of our CPUs, both PLCs and touchscreens, have Ethernet as standard. So communications, connectivity to external devices is the simple way to look at it. And this could be a PLC talking to a barcode reader, an RFID tag reader, a variable speed drive to determine speed and direction, to another PLC to share data from a bit of hardware further down the production line, to a touch panel or operator interface, giving user actual data and the ability to control the application, or talking to something like an engine management system using a dedicated protocol, which we'll talk about in a moment. So this is simple communications or connectivity to external devices. So an industrial communication protocol, what is it? Well, basically, it's a packet of data where the rules and the format of that data are transferred around a network of multiple devices. And because we know that protocol and that device can talk that protocol, whatever is being sent around that network, those devices on the same network can understand and talk the same language. These protocols are typically open protocols or dedicated. They are serial or Ethernet, and one-to-one, like RS-232, or one-to-n or one-to-many, like RS-485 and Ethernet. On the right-hand side there, we've just got some examples, and there's many more of some of the protocols that you most commonly see. So Modbus RTU is a serial network based on RS485. Modbus TCP, exactly the same protocol, so the data packet and format is the same, but now we're using Ethernet as its communication platform rather than serial. Ethernet IP, CAN J1939, mentioned briefly a moment ago talking to engine management systems. The protocol there is CAN J1939, and we have dedicated PLCs that talk that language. So if you're manufacturing generator sets or something with an engine in it and you need to know the performance data of that engine, fuel consumption and everything else, you can bring that back on that CAN J1939 protocol. Profinet, CC-Link, and BACnet, Building Automation and Control Network. These are just some protocols that you'll hear banded around in the industry. If we look at the highlighted ones in green, these are protocols which we support within the IDEC PLC hardware. So Modbus RTU, serial, Modbus TCP, Ethernet, Ethernet IP and BACnet are available on the FC6A Plus PLC, and CAN J1939 is available on the FC6A all-in-one type. So to recap the four fundamentals, input, both digital and analog, coming from devices on your machine or your processor or your control panel, going to the PLC. The PLC then effectively uses its special functions or its program to determine what to do with those inputs, and that then influences the outputs that you want to switch on or off, to open valves, close valves, and so on the machine. We then have the communications. So if your PLC needs to talk to a HMI or a variable speed drive or something else on communications, we have that to consider as well. So that's the four fundamentals that we want to look at when looking at the PLC. So once we've collected all that application data, we've got a basic requirement table. So your DI, your DO, your AI, your AO, your special function communications comes up with a typical IO example, as we've got on the right-hand side of the screen there. We've got 54 digital in, 39 out, 3 analog in, 2 analog out. We need PID functions, so we can assume there's some kind of temperature control perhaps going on here. And also we need communications, Modbus to a variable speed drive, and Ethernet to a touch panel. Now we'll come back and revisit this example in a moment, but before we do that, just want to talk you through some of the hardware that we would look at today for these applications. At a glance, we've got the FT1A Touch with a maximum I/O capability of 158. We then have the FT1A Pro and Lite, which has a maximum I of 196. A clever way of networking, which we can talk about when we talk deeper about your applications. The FC6A all-in-one has a maximum I/O count of 520, and then the FC6A Plus has a massive 2060 I/O capability. In more detail, the FT1A Touch provides a 3.8-inch color touchscreen. A mono version is also available. It has 8 digital inputs and 4 digital outputs, and 8 analog inputs and 2 analog outputs. As I said, it can be expanded up to 158 I/O and has the ability to add additional analog and communications to the back of the unit. As standard, the unit comes with Ethernet and 2 serial ports, either RS232 and 485. All of those can run concurrently. The FT1A Pro and Lite, this is a basic PLC where you have Ethernet as standard. Optional serial communications can plug into the front of the unit. The Pro has a local display where you can show both the ladder program, you can also show error messages and overlay data and rewrite data to and from working out of the PLC. Note though that FT1A has no analog output in the Pro and Lite. Then we move on to the FC6A all-in-one. With this CPU, we have Ethernet Modbus TCP, or Ethernet and user communications as standard. We have serial RS232 and 485, which is configurable inside the program. We have an SD card for that all-important data logging of events or recipe handling. It has 1 integrated analog input channel. It has an option for a local display and also a web server handling email and a website, which mounts to the left of the CPU. Of course, any expansion I/O mounts to the right of this CPU. Then we look at the FC6A Plus, our flagship. It has everything that the FC6A all-in-one has, but now we have 2 Ethernet ports. We support now not only Modbus, but also Ethernet IP and BACnet. because we've got 2060 as a maximum I/O, we can have this across 10 extension systems. Each of those extension systems could be up to 7 racks, or 7 I/O cards, I should say, and they can be up to 100 meters apart. This is a very neat way to achieve remote I/O from your PLC. The FC6A Plus also has the embedded web server, handling the email and website capabilities of our processors. So back to our example, the one where we had our 54 digital in, 39 digital out, 3 AI, 2 AO, PID, and then Modbus to a drive and Ethernet to a panel. For this solution, just to give you an idea, I've selected the FC6A all-in-one type because it provides us all the communications that we need and also meets the I/O requirements. So the base PLC is a 40 I/O PLC offering 24 digital in, 16 digital out, and 1 analog in, albeit in this application we won't be using the analog input. It has 2 16-way input cards, adding another 32, so this gives us a total of 56 inputs. We then add a 16-way and an 8-way digital output, so we have 40 digital out. We then add 1 expansion module, which gives us all of our analogs, which has 4 channel in and 2 channel out. So in total there, we've got the solution that we need for a price in the region of 695 euros. This is based on the FC6A all-in-one CPU. Another example, smaller PLC application this time, where we have only 11 digital in, 7 out, 3 analog in, no analog out. We want a local display to display error messages and fault information and process data to the user of the machine. And at some point in the future, they recognize the need for gathering data to a management system. So they want the ability to talk Modbus in the future. So for this, I've selected our FT1A Pro type, so it has the display, 24 I/O, which is split 16 inputs and 8 outputs. Out of those 16 inputs, 4 can be analog. So we easily meet this requirement of 11 digital and 3 analog out with this unit. And here we have a system price in the region of 219 euros. So this is utilizing the FT1A Pro series PLC, which has the embedded fixed display. So that brings us close to the end of this webinar. What I want to say is we are here to help. We have the capabilities and the skill sets to support you in your applications and your need, whether you're producing food, whether you're in filtration, tank filling, tank emptying, level control, sheet metal work, or process flow, CIP, and so on. Solutions we have within our grasp for this hardware. So thank you for your time. Thank you for listening. I'm now ready to answer any of your questions, so please feel free to add them to the right-hand side. Thank you. Just scanning the questions for you. Okay. Good question. So I mentioned during the webinar, the communication distance for our RS232 is typically 10 to 15 meters. I've been asked what's the communication distance for RS485. Well, typically the RS485 is much longer in terms of its network capabilities. From the standard RS485 port on the front of the PLC, the maximum distance is 200 meters. The same with the expansion module that would plug into the front of the FC6A. However, we do have one module that can mount to the right of the CPU, which delivers RS485 to a distance of 1.2 kilometers. So if you do have a hardware which is mounted a long way from the main PLC, this can be achieved using RS485. Okay. Programming software. Of course, every PLC needs some software. It needs to be configured, and that configuration is done by IDEX Automation Organizer. Inside the Automation Organizer suite, you have software for our PLCs, the FT1A and the FC6. You also have software included for all of our touch panel products, the HG series from 4.3 to 15-inch color touchscreens. And you have a separate piece of software for the FT1A Touch, the small combination PLC HMI, which we mentioned earlier on. The cost of this software is in the region of 300 euros. Once you purchase that software, all of your support, and any upgrades to that software in the future, whether we add new hardware, whether we add new features to the PLC, or even to update firmware within existing PLCs, all of that is free. So it's a one-off purchase to get into the family, and then the run-on cost from that is zero. Expansion modules. Okay. Of course, every PLC, we talked about the main CPUs today, and I touched on some expansion on one of the examples. The expansion units for this typically are based around digital control or digital inputs and outputs and analog inputs and outputs. There are many. Digital-wise, we do 8, 16, and 32-point digital in and digital out, both relay and transistor. The 32-point is only transistor. We have many analog type expansions, 2-channel, 4-channel, 8-channel, and then combinations of 2 in and 1 out, and 4 in and 2 out. And then we have some dedicated expansion as well. I mentioned Serial Communications RS485. If you need to talk 1.2 kilometers, you need a special card for that. Otherwise, the standard RS485 is 200 meters off the front of the CPU. And then we do some dedicated PID controller modules, which have their own CPU and processor for those delicate applications for PID when it's needed. Question about USPs that's put IDEC apart from its competition. I think fundamentally this is the if we look at the FC6A first of all, the FC6A across the series, the FC6A they all have the same communication technology as standard. So we have serial 232.485, we have Ethernet, we have the SD card. Very often these features are on the higher end of some of our competitors. So this is quite important that we have this standard across the series. The lowest cost FC6A all-in-one is about 160 euros. So this becomes a very affordable solution in many applications. I think that's, for me, is one of the key points. And then, of course, if we look at the FC6A Plus in applications where you need remote I/O, the way in which we can do that with the 10 extension racks up to 100 meters apart is a very neat way to achieve remote I/O at a very low cost base. So I think these are some very technical USPs that we have to offer. Okay, there's a question about webinars like this one. What PLCs would we advise for beginners to purchase and to familiarize? To be honest, I would buy an FC6A C24, either AC or DC powered for my kickoff. I think it's a PLC that really sits very well. It's in the middle of our range. I think price and performance, it's a perfect fit. You can also download a demo version of our software if you want to learn. This will run for 30 days, full functionality. So you can download that software for free, source a PLC and start playing with it. So I would go with FC6A C24 R1CE as my standard, let's say, training kit. We will be doing some starter kits in the beginning of 2021, so watch this space. It might be a nice way for you to get on board. A library of webinars. Yes, we do have certainly some webinars that are viewable, and if you want to contact me afterwards, I can give you the necessary links for those. How many expansion cards could be connected to an FC6A all-in-one CPU? With the FC6A all-in-one, actually it's two types. With the FC6A C16, the baby, you can have 4 expansion modules mounted directly to the left, so to the right of the CPU. Then you have to put an extension power supply in, and then you can have a further 8. With the FC6A C24 and 40, you can have a maximum of 15 cards. Again, after the first 7, you have to go to an expansion module. Are there additional high-speed inputs available? No, the FC6A has the maximum of the 6 high-speed counters, and we don't do a separate high-speed counter card. If you need to have more, then I would suggest we bolt 2 PLCs next to each other, sharing data and sharing that high-speed information. If you'd like to discuss that in more detail of how we would do that in a fast way, because we would typically use data link, a dedicated protocol for IDEC between those 2 CPUs to share that data really quickly. But that's how we would do that if you needed to get above 6 high-speed count inputs. Have got any experience with protocol TCAN? The answer to the question is no. We can't talk TCAN. I would want to delve into that a bit deeper. So if you want to contact me after this webinar, we'll talk about it just to find out what's behind it. I think TCAN is possibly a Beckhoff protocol, but I'm not quite sure. I have to look at that one. Question, can we realize communications of PLC via a Wi-Fi adapter? Principally, yes. If you were to connect your PLC to some kind of Wi-Fi router, there is no reason why that wouldn't work. What we do have off the shelf is Bluetooth capabilities. You can plug a Bluetooth module directly to the front of the PLC. But Wi-Fi, I would have to look into exactly how we do that. I don't see any reason why it wouldn't be possible, but you'd have to go via some kind of Wi-Fi router to achieve that, not directly from the PLC. Okay, that answers all the questions that I've got up here. So if you've got any more, my contact details you can see here, so feel free to take a screenshot. You will be sent this webinar anyway for you to refer back to. So please do get in contact with us. And I invite you to follow IDEC EMEA on LinkedIn. We are gearing up more and more communications via that platform, and you will see the latest news coming from us. So thank you for your time today.